Good evening, everyone, and welcome to this lecture. In this lecture, we are supposed to finish your topic on photoelectric effect, and probably I thought that we will be able to finish it yesterday, but could not. Anyways, man proposes, God disposes. That is how life goes on. So we'll try to wind it up here. I think in the last class we were doing questions on your photoelectric effect. We are still not done with all types of questions, so we'll continue on that. This is the question I think that we were discussing. Let's start with that question. The lowest frequency of light. What do you mean by lowest frequency of light? The lowest frequency of light that will cause emission of photoelectrons from the surface of a metal whose work function is 1.65 electron volts. What is the lowest frequency which can emit electrons from this? Again, this is a question taken from one of your previous exams. The questions that have come in your previous exams, whatever exams they are, they keep on getting repeated. So if we can do a lot of questions, and this chapter is only about solving a lot of questions, looking at the diagrams, getting them done, we should be doing good. So how do you get the answer here? Can anyone tell me the answer? How will you get this? How will you get this? Yes, beta. Do we remember the equations and everything, or shall I go through them once again? You are going to get a question from this chapter, beta. From this chapter and X-rays, you are going to get questions, and these questions are going to be very damn easy. Okay. So if you can do them correctly, you will be doing good. I'll give you 2 minutes. Yes, anyone with an answer, beta? No one? Shall I do it? All questions have we done? Yes. Shall I give you the answer? What is the lowest frequency? Basically, they want to ask the threshold frequency. When they ask the lowest frequency, that is the threshold frequency. When they ask the largest wavelength is your threshold wavelength. So you can just note it down as a point. Lowest frequency, that means they are asking you the value of F naught. Now we had done a similar question in the previous class where, see, they had asked you the longest wavelength. That was the first question that we did. Longest wavelength means threshold wavelength. Lowest frequency means threshold frequency. Do we understand this? Yes? Everyone understands this? Okay. So you have to find the threshold frequency. How will you find out threshold frequency? So you can first find out the threshold wavelength because you have the shortcut formula for that. You can find the threshold wavelength. How did you find the threshold wavelength? Lambda. You can find it by HC by work function. And I told you the shortcut formula for HC and work function. You can put 12,400 here and you can put 1.65 over here. Remember, you have to get an approximate answer, right? And here, if you look at the terms, everything is getting 4 4 4 4. So you basically need to get the correct value of the power, nothing else. So how much will this be? You can just take it as 1.6 just to make your calculations simpler. You just take it like this and get an approximate answer. It's just a division. I think the approximate answer that I'm getting is 7,500 Armstrong unit because you will get the answer in Armstrong unit. Now, once you get the value of lambda naught, you can find the value of F naught from C divided by lambda naught. C is 3 into 10 raised to the power 8 divided by 7,500 into 10 raised to the power minus 10. You basically have to find out the correct power. That's it. If you find out the correct power, it's just a case of you are doing the multiplication correctly. If you can do the multiplication correctly, you will end up with the correct answer. And the answer that is given in the sheet is 4 into 10 raised to the power 12 hertz. Did you get this?
Yes, sir.
Okay, so that is the answer for the previous question. Okay, let us move on to the next question. See, they make questions in different ways. What you have to understand, if you can remember the pattern and you can do the multiplication and calculations correctly in the correct time, you should be able to solve those questions correctly. This is the next question. Light of frequency 8 into 15 hertz is incidence on a substance of photoelectric work function 6.125 electron volts. What is the maximum kinetic energy of the emitted photoelectrons? Again, this is previous question. This has come with different values in different years of your NEET. See if you can do this question fast. Remember, it's all about you able to do it fast. Yes, but anyone got the answer? 2 minutes I'll give you. And then I'll tell you some tricks to get it correctly, quickly. Remember, beta, it's all about you able to get it quickly enough. If you can get it quickly enough, well, the problem is solved. Don't have to look for anything else if you can do it quickly enough. Everyone knows how to do this, na? We're only caught in the calculation part. Yes or no? We don't know how to do this. Seems like you are caught somewhere. Okay. I think I must step in. I've given you enough time. So that means you are stuck somewhere. Okay. Shall I do it? See, you have to find the maximum kinetic energy. Just take a deep breath and look at the equation. So, energy of the photon, that will be equal to your work function W naught plus your kinetic energy maximum. So basically, to get the value of maximum kinetic energy, you have to find the energy of the photon and subtract it from the work function. Do we understand this? You just have to do this. Now to find this work function is already given to you as 6.235. The only thing you have to calculate here is the value of this E in electron volts. Remember, yes or no? Now how do you get the value of this E in electron volts? You multiply it. The value of this in electron volts is H, Planck's constant, into F. The frequency that will give you the energy in joules. You have to divide it by the value of E to get it in electron volts. Do we understand this? Yes or no?
Yes, sir.
So you do the multiplication here. 6.6 into 10 raised to the power minus 34 multiplied by what is the frequency, 8 into 10 raised to the power 15 divided by what is 1.6 into 10 raised to the power minus 19. And you can see your calculation will become pretty simple. Minus 19 minus 34 will go 15 minus 15 times, yes or no? Minus 15 and plus 15 will just go away. 8 will go 0.2 times. See, the calculation becomes so 0.2 and 0.2 will go here. So it is 66 divided by 2. Answer is straight away 33 electron volts beta. This is how you do the calculation. You do not do calculation like this. First you multiply h by f. You get yourself in multiplying h by f. Then once you get the value of f h by f, then you divide it by e. You again are caught in the calculation. You do calculation only once. You put everything together and then you will see things are going to get cut. See, everything got cut. Do we understand this? Yes or no?
Yes, sir.
Now you just subtract 6.125 from 27. You don't have to do it. You can straight away mark the answer as 27. Yes or no? Do we get this?
Yes, sir.
Everyone understood this? Yes or no? Can I have raise hands from everyone? How you are supposed to calculate, that is what you have to think. Do the calculations at the end. Even if you do a mistake, the mistake will be at the end, and lots of things are going to get cancelled. Trust me on this. A lot of things are going to get cancelled. Once they get cancelled, then you can very easily get the answer. Can you move on to the next one?
Yes, sir.
This one. I've seen this question in previous exams.
Sir.
Can you solve it now? Yes, bacha, do we have any answer?
1 minute, sir.
Okay.
Sir.
Yes, beta.
1:4.
1:4 is correct. Everyone got this answer? How many of you got this answer? Girls in the other class. What about here? Other class? Anyone got this? Abhiram got this. Well done, Abhiram. How are you supposed to do this? You just have to apply what? The equations that we have done. You apply it once, you apply it twice, and then you probably divide them and you end up with your answer. Yes or no?
Yes, sir.
So let me do it for you. Light of two different frequencies. have photon with energy 1.5 and 2.5 successively, eliminates a metal of work function 0.35. What is the ratio of kinetic energy? So you just have to find the ratio of kinetic energy. You must remember this formula. Kinetic energy Ke will be equal to energy of the photon minus the work function W naught. So if I call it E1, Ke1 will be E1 minus W naught. So it will be E1 is 1 minus 0.5. The kinetic energy of the second one will be equal to E2 minus work function. E2 is 2.5 minus 0.5. You just have to divide. So kinetic energy of 1 divided by kinetic energy of 2 will be 0.5 divided by 2, and that would be 1 is to 4, and 1 is to 4 is the answer which is correct. 1 is to 4 is the answer which is correct. Do we understand this, everyone?
Yes, sir.
Got this? See, these are the types of questions that are going to come. Okay. I had a couple more. Okay, this we have done. Yes, again a question that has come in engineering exams previously. Now it comes in your medical exams. Again, this is a question based on not much calculation, but more on theory. So can you give me the answer for this one? If yellow light is incident on a surface, no electrons are emitted, while the green light can emit. If red light is incident on the surface, then which is the correct option? A, no electrons are emitted. B, photons are emitted. It's a great option. Photons are emitted. C, electrons of higher energy are emitted. D, electrons of lower energy are emitted. Which is the correct option here? Yes, bacha. You will get many questions like this. I will show you questions from your previous year papers as well. How do you solve questions like this? Shall I do it? Got caught. Now remember, I've told you this many times, and when we solve question, it's good that such questions come up. You know this, right?
Yes, sir.
That is the answer, sir. Now remember this, Vibjor. Who has got the lowest frequency? Now, who has got the lowest wavelength? Who has got the lowest wavelength? Shortest wavelength, my dear friends. Which light has got the shortest wavelength? Which one, beta?
Violet, sir.
Violet. Well done. So just note this down. Oops. Wavelength increases in this order. This is how the wavelength increases. What about the frequency? Frequency decreases in this order. You just remember this. Frequency decreases in this order. Wavelength increases in this order. Now remember, when we talk about photoelectric effect, it is direct. I mean, energy is directly proportional to frequency and inversely proportional to wavelength. That means if the wavelength is more, energy is less. If the wavelength is less, energy is more. If frequency is more, energy is more. Frequency is less, energy is less. Now take a deep breath like this. Read the question carefully again and give me the answer, because I've seen many questions comes on this WebGeor. Sometimes they ask to refractive index. I told you refractive index is also inversely proportional to wavelength. Yes or no? The light which has more wavelength will have less refractive index. Yes or no?
Yes, sir.
So many questions come on this WebGeor. Take a deep breath. Now tell me the answer. Shall I help you? See, yellow light cannot emit. This cannot emit. But green light can emit. That means green light is somewhere near the threshold frequency or threshold wavelength. That means light which has less wavelength compared to green will emit. Light which has more wavelength compared to green, more wavelength compared to green cannot emit. Yellow cannot emit. Orange cannot emit. Red cannot emit. Do we understand this?
Yes, sir.
Blue can emit. Indigo can emit. Violet can emit. Now I ask you this question: which light will give you electrons with maximum energy? Which color will give you electrons with maximum energy?
Violet, sir.
Violet, gentlemen, will give us electrons with maximum energy. So they can ask the question in this fashion also. Bacha, just remember this diagram that we have drawn. Wavelength increases from violet to red, and frequency decreases from, sorry, frequency increases from red to violet. Do you understand this? Yes or no?
Yes, sir.
Then comes this question, and then I'll take you to some previous year questions. Have you noted it down? Shall we move on to the next question?
Yes, sir.
Sir.
Yes, beta. Okay. Remember, they're always asking questions on ratios. Ratio of this by this, ratio of this by that. These are very, very famous pet questions of your NEET. So be very careful about these questions. These are some of the pet questions of your NEET. So this is one of those questions. And I hope you can give me the answer for this one. Bacha, anyone with an answer?
Sir, option A.
Option A, 1:1. How did you get? Shall I do it? Okay. Which equation we have to apply here? To find the ratio of kinetic energy. So kinetic energy maximum is E minus work function. Yes or no?
Yes, sir.
Let me find out the kinetic energy of the first one. E of first one will be H into F. Yes or no?
Yes, sir.
Minus work function are in the ratio 1:2. So let me call it as W. Okay. Now let me find the kinetic energy of the second one. Energy of the second one is 2 into F. Yes or no?
Yes, sir.
And work is in the ratio 1:2. So this will be 2W. Yes or no? You have to find the ratio. So KE1 by KE2 would be what? You can take 2 common. 1/2. Do we get this, bacha?
Yes, sir.
How did you get 1:1? It is not 1:1, it is 1:2. Do we understand this, bacha?
Yes, sir.
Now see the type of question that come. Most of the questions from this chapter, they might not require so much of calculation. They would just require you to know simple facts. For example, this question, see, previous year question, same question repeated many times. The energy E of a photon is hv. The momentum of photon, everything they have given is h by lambda. What is the velocity of the photon? Yes. Don't have to write these questions, bacha. You can just give me the answer. There's no point of writing these questions. See, what is the answer? The answer is E by P. Yes or no? Have you seen this?
Yes, sir.
But the answer is also this, sir. So in many a times, what happens is the question that has come in previous year papers, they have flaws like this. Photons always move with the speed of light. So answer is also this. The answer is also that. Okay.
So what will be the primary answer?
I don't know. I would mark both. So sometimes I've seen a lot of mistakes in questions of previous year NEET. I mean, not now, but let us say 4 or 5 years back, they used to have a lot of mistakes in those questions. But now since this NT has taken up NEET, the mistakes are not there. This one. See, these are the questions that are going to come in your exam. You should be able to answer them fast. Yes, what is the answer for this one? It all just depends on how much you remember. The momentum of a photon. What is the momentum of a photon? See, you have to be quick in answering this. I've already given you everything. Yes or no? You have to go back and look at the momentum. I had given you everything. See, I've given you everything. Everything. I started the chapter with this definitions of everything. See, I had given you everything. You'll have to remember it better. See, we had solved some questions on this. Lambda is h by p. So p is h by lambda. See, given you so many things. See, even in matter waves, I told you lambda is h by p. See, momentum is lambda is h by p. See, so many times momentum of a photon. You'll have to remember this better because most of the question that you are going to encounter will be like this, particularly in this chapter. This chapter, because the calculations are so much, they might not give you a question based on calculations. They will probably give you a question which is based on the ratios, the type we had done today, or straightforward questions like this one. Do we understand this? These are the type of question that we are expecting from exams. See, this one, a very famous question that has come many times. All theoretical. Most of the question from this paper would be in the theoretical range. Give me the answer for this one. The number of photoelectrons emitted per second from a metal surface increase when? 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 Which is the correct option? These are the questions that are going to come, beta. Don't have to write them. Just give me the answer. Number of photoelectrons emitted per second. That means photoelectric current. They might not ask you straight away photoelectric current. They might ask you question like this. On what factor does the number of photoelectron emitted depends on? Yes. What is the answer? It depends on? Huh? Don't know. Intensity of light increases. Abhiram is doing great in this topic. Well done, Abhiram. That is the correct answer. Intensity of light. It depends on the intensity of light. Option D is the correct answer. Well done, Abhiram. Rest of us, do we understand this? Yes or no? Why there were no answers coming from anyone? Well done, Abhiram. See, these are the type of questions that we are expecting in this chapter. See more. Yes, keep up the good work, Abhiram. And you are doing good now. As I can see it, there is a distinctive change in the way you are answering these days. Well done. The photoelectrons emitted from a surface of sodium metal are such that simple theory-based questions. They are all of same frequency. They have the same kinetic energy. They have the same de Broglie wavelength. All PMT questions, all NEET questions. They have speed varying from 0 to a certain maximum. Yes, bacha. Yes, bacha. Which one? Which one? Which one? Which one? If it is taking so long, that means you don't know the answer. You know the answer, you know it darang. Otherwise, padang. And the answer is darang. They have 0 to maximum kinetic energy. They have 0 to maximum velocity. Do we understand this or just gone above our head saying bye bye? I'm going. Don't worry about me, sir. Count me out. I'm gone. Do we understand this? Yes or no?
Yes, sir.
These are the type of questions we are expecting in the exam. Next one. The retarding potential for having 0 photoelectric current is proportional to the wavelength, increases uniformly with the increase in the wavelength, is proportional to the frequency, increases uniformly with the increase in the frequency. Retarding potential. So again, the answer here would be C, or it could be also D because it is proportional. Frequency is proportional to V naught is proportional to frequency, or it is a straight line. Do we understand this? Now again, C and D options are confusing you over here. Do we understand this? So many questions of this nature have come where you have confusing options, and that is why I hated PMT, because even they give 2 right answers, and which is more right among the right answers? Well, you cannot find out more right among right, because right is always right. This one, this is the original question from one of the JEEs, but as you can see, it has come in PMT as well. So now you can answer this, the last one for today. If photoelectric cell is illuminated by a point source of light 1 meter away, if the source is shifted to 2 meters, then what will happen? If you make the distance twice, what will happen? Remember, when you talk about the energy, energy depends on frequency. Frequency still remains same, so this option is wrong. Do we understand this? Energy depends on frequency. So this option is also talking about energy, doesn't change, frequency doesn't change. The only thing that can change is the photoelectric current. Now, how does the photoelectric current change? Photoelectric current means the number of electrons. So basically the number of electrons of the photoelectric current is going to change. Now, photoelectric current depends on intensity, yes or no? For a point source, I told you the answer. For the point source, the intensity is inversely proportional to distance square, yes or no? Well done. The intensity is proportional to distance, inversely proportional to distance square. Distance becomes twice. So intensity becomes 1 by 4. If intensity becomes 1 by 4, current becomes 1 by 4, and your number of photoelectrons also become 1 by 4. JEE people were not able to answer this. The question was not just this. The question had some part as well. This is the original question taken from one of the IITs, previous year IITs. But after that, it has come in your NEET. Okay. So this is it. I've done enough questions that are more than enough for you to solve any question. Rest of the question are there in your sheet, and I hope that you are doing that sheet religiously. Are you doing it? Please do that sheet. If you can do that sheet, I can give you guarantee that questions will come from this sheet or from my class. So take care. In the next class, that is tomorrow, we are going to start with X-rays, which are of more importance to doctors than to us. Take care. Have a nice day. God bless you all.